right, there was a question on the master set.
Yes. I think that was question number 2.
And I don't have a copy here, so. What's the question?
So it was number 2, part B. If this circuit consists of a DC power supply and a 2,345 ohms resistor, and if Z is the cross section just before the resistor of the end with the higher potential, what is the current in the wire just after the lower potential side of the resistor?
Okay.
Um,
What's your speculation?
So I assume that the resistor wouldn't change the amount of current coming out of the system, and so since it said just right after I derived the equation for the current, and then I just plugged in 1 for the time, like 1 second, and 1 with whatever value I had. I don't know if that's correct.
Whatever. Sorry, can you see the question again? Piece of wires, you got the equation. So formula for the current at section Z, I assume that's not the question you had. And so all you did was just put down the same answer you had for A?
Well, it was an equation, so not B, I just plugged in a number and then,
Into the, what you had for A?
yeah.
Yeah. That's it. The whole question was meant to look scary, but the current in equals the current out.
So, once you find the derivative, you just use the equation and just plug that
Yep.
resistance number. Okay. I had a problem with C. C, it was,
Look at it.
was the equation which describes the voltage of the power supply.
So it's just I have a DC power supply and a resistor, right? Is that the, and you found the formula for the current in part A?
Yeah.
The voltage coming from the power supply. The voltage from the power supply, whatever I gain here, I'm gonna lose here. So the voltage for the power supply would be the same formula as the voltage, the potential difference or voltage for the resistor. And so delta V is equal to IR, so you would just take your formula for current and multiply times R.
Wait, so was it okay that I plugged in 1 for B for the equation?
Oh, 1 for the time?
Yeah.
I have to look at it again.
Make it this.
So it's.
VRC, are we finding the voltage of the resistor or the pattern?
So there are only 2 things in the circuit. Whatever I gain going across the power supply has got to be what I'm losing across the resistor, so the potential difference, the magnitude of the potential difference would be the same.
I'm wondering if I need a negative.
No. I guess technically, if you put the negative in there, it's not wrong, it just depends on which way you're going across the power supply. I was not picturing the negative. let's see, Z's cross section just before the resistor and the height end, what's the current? Oh, okay. The intent is the formula for Z doesn't change, so if you can get across that it's the same before as after at any moment.
So you just put it's the same? Or,
Yeah, that would work too.
oh, cause I thought it was asking for like a numerical value.
The main point of that question was to recognize that a resistor affects the entire circuit. It doesn't affect just, it's not like a traffic jam where you're cruising along and then all of a sudden you have to slow down. You're going the same speed the entire time. That's the intent of the question.
Okay. So it'll be okay if I just write it's the same?
Yeah,
Okay.
and it's being recorded, so we have backup in case later I change my mind.
That's why I was confused. I figured it was something else missing, but it's the same.
You were looking for more sophistication than I was capable of when I wrote that question. Yeah, part of that question where I gave you the formula for the charge and you took the derivative. I was trying to force a calculus problem into that section, but that's part of that. And since I was there, I thought, oh, well, let's just check this other thing too.
Oh, and then on the last one, on 3, when we're trying to find the number of windings, should I take into account the thickness of the wire, or should I just do the width of the cylinder?
So, if I'm recalling that one correctly, you're finding the length based upon, say, I gave you the material, I assume copper. I told you the resistance.
Yeah, we have the resistivity,
So you're trying to find the length, so you find the length of the wire. So you're using R equals rho L over A, I believe.
Yeah.
So the diameter of the wire is necessary to find the cross-sectional area.
yes.
Resistivity, you'll look it up. R was given, so you find L. And then the number of coils, if you know I assume I told you the diameter of a coil?
Yes, or of the cylinder that it's wrapped around.
Okay, I told you that diameter.
So should I just use that, or should I add the diameter of the wire?
The original intent was you would add the diameter of the wire, but I think in practice, I have not nitpicked that one. But the original intent was that you would include the diameter of the wire.
And I just put the source down for the resistivity.
Okay.
That's, okay.
Yeah.
So we were supposed to look it up.
Yeah, I mean, there's a range there that is acceptable.
Yeah, I found like different values, so.
It's usually somewhere in the 1.7 times 10 to the -8 range. Give or take, 0.02 or 0.04.
Also, I couldn't find the online assignment for this. I was at 28.
The online for submission. If you just don't deserve to have it, maybe that's it. Yeah, okay. Did you send me an email saying it's not there? Did someone send me an email saying it's not there? Something along the lines of, dude, where's my submission button? And no doubt I will read it, say something incredibly witty, which most people would find incredibly funny. But it will never be funny again. Other questions? Christopher, are you sending me an email right now? Okay. Could you throw in there, something along the lines of, do check the wording on your problems? All right. Are we ready?